Let's delve into the fascinating world of fluid dynamics, where we can uncover the secrets behind why some objects float while others sink. At the heart of this phenomenon lies the principle of upthrust, also known as buoyancy, which is a force that acts in opposition to the weight of an object submerged in a fluid. To understand this, we must first consider what happens when an object is placed in a fluid, whether it be water, air, or any other substance. When an object is submerged, it displaces a volume of fluid equal to the volume of the object itself. This displacement creates an upward force, or upthrust. The upthrust is determined by the weight of the fluid that has been displaced. According to Archimedes' principle, the upthrust on an object is equal to the weight of the fluid displaced by that object. So if we take a potato and an apple, we can see how this principle plays out. A potato, being denser than water, displaces a volume of water that weighs less than the potato itself. The weight of the potato exceeds the upthrust, causing it to sink. Conversely, an apple, which has a lower density than water, displaces a volume of water that weighs more than the apple. In this case, the upthrust is greater than the weight of the apple, allowing it to float. This interplay between weight and upthrust is crucial in determining whether an object will sink or float. Now, let's explore the conditions under which an object will float. An object will float if the weight of the fluid displaced is equal to the weight of the object. This is the equilibrium point, where the forces balance out. Imagine a boat on a lake. It floats because the weight of the water it displaces is equal to the weight of the boat itself. If we were to add weight to the boat, it would sink deeper into the water until the weight of the displaced water matches the new weight of the boat. If the boat becomes too heavy, surpassing the upthrust, it will sink completely. This concept of buoyancy is not limited to liquids. It also applies to gases, albeit in a different manner. Atmospheric pressure plays a significant role in this context. Atmospheric pressure is the weight of the air above us and decreases with height. As we ascend a mountain, for instance, the amount of air pressing down diminishes, leading to a decrease in atmospheric pressure. The reason atmospheric pressure decreases with height is that the air is composed of molecules that are pulled toward the Earth by gravity. At lower altitudes, there is a greater concentration of air molecules, resulting in higher pressure. As we move higher, the number of air molecules decreases, leading to lower pressure. This is why, at higher elevations, we often experience a sensation of lightness. There is less air pressing down on us and therefore less atmospheric pressure acting on our bodies. In conclusion, the relationship between buoyancy, weight, and fluid pressure is a remarkable aspect of physics that explains the behavior of objects in fluids. The principles of upthrust allow us to understand why some objects, like apples, float effortlessly on the surface of water, while others, like potatoes, sink to the bottom. The interplay of density, displacement, and gravitational forces shapes our experience of the world around us. Likewise, the decrease in atmospheric pressure with height provides insight into the dynamics of gases and the environment. By exploring these concepts, we gain a deeper appreciation for the forces that govern our physical reality, revealing the intricate balance of nature that surrounds us.